So my name's Ben, and today we're going to talk about minimum viable migrations. As I mentioned, I'm Ben. I'm the CTO of aleio, which is a serverless consulting company helping organizations of any scale adopt serverless, from startups building their initial MVPs through to airlines and banks adopting serverless at a very high scale. I'm also the editor of the Serverless Transformation blog, podcast, and newsletter. So if you're interested in serverless and want to keep up to date, you can find that by searching on Medium, or you can find the links to all of that on the aleio website. Finally, I'm an AWS serverless hero, which means I get to speak at events like this and work with people like Eric on the future of serverless, which is really exciting. So today we want to talk about minimum viable migrations. And a lot of this talk comes from my experiences of helping large organizations to adopt serverless. We've typically seen larger sort of migrations to serverless as being very waterfall and not so agile. And we're going to go through the reasons for that. But MVMs as a framework really came for us trying to find an easier way for people to adopt serverless in a more iterative way. So today we're going to look over what Agile is. I'm sure we all know what Agile is. But then we're going to see why it typically doesn't get applied to cloud migrations. We're then going to look at how we could maybe address those challenges with minimum viable migrations. And core to MVMs is the concept of event-driven architectures. So we'll look at EventStorming as part of DDD to generate our list of events. And then we'll look at injection strategies for a migration, how eventification and anti-corruption layers help us to integrate with legacy, and then finally how we build a roadmap for our MVMs. So what is Agile? I'm sure a lot of you have a lot of strong views on this, so I'll go quite quickly. But in most definitions of Agile, it involves discovering requirements with collaborative efforts, involving end customers, and getting feedback. And going hand in hand with Agile is typically leveraging an MVP approach. So we build just enough features to provide feedback and be useful for us to test our assumptions early. And I'm sure most development teams in the room, if they're going to build a new greenfield product, would by default build it in an agile way using MVPs. But when we move to migrations, that's not necessarily the case. Now, going back to an MVP for a more greenfield style application, we typically do this for a number of reasons. It lets us test our hypotheses earlier, be them technical or about product market fits. It lets us learn a lot faster from our customers and also our technology. We reduce a lot of waste. We ship value to customers faster. And we validate a lot of our assumptions, again, be them technical or from the markets. But now I want you to forget Agile. And if you work for a large bank, you probably already have. We're going to move on to cloud migrations, where there's a slight difference in how we build. So a cloud migration, there are probably a lot of different definitions, but for me, it's really moving digital business assets and operations to a cloud provider or from one cloud provider to another cloud provider. I'm not saying you can move from AWS, but it's a wrong room to make that joke. But a migration for me is really a shift in domain. So moving from domain A through to domain B. That might be moving in a traditional cloud migration from on-premise to cloud, or it could be a migration in language from something like .NET to something like Python. It could be a structural migration from a monolithic application through to an event-driven microservice architecture. Or my personal favorite could be a cloud modernization, where we move an application that's maybe already lifted and shifted into cloud to make the best use of a cloud provider like AWS, using serverless to build really state-of-the-art architectures. But does this sound like any of those migrations? If you've done any of those migrations in the past, did it feel like you were discovering requirements in a collaborative effort with cross-functional teams where you were building just enough features to get feedback? Typically, most of the migration projects I've seen have not taken that approach and have gone for much more of a big bang release. Let's rebuild everything, release it, and see what happens. And why is this? Why are we typically not taking an agile approach to migrations? Well, typically, a migration, let's say it's a cloud migration, a lift and shift, or a refactor migration, we'll take a waterfall approach where requirements are discovered, we make a design, we move to implementation, and finally we have validation. And if you're very unlucky, something called procurement jumps in the middle and makes everything a lot slower. But even in the states where we don't have procurement getting in the way, there's an issue. Our system as is, the existing system that we has a number of features. Things like SSO, things like email, maybe core feature X, and maybe some legacy feature that isn't necessarily used by all customers. If we want to migrate and release, well, we have to have a user experience that still has all those features and functionalities. And this leads to feature parity paralysis. This is where maybe we've rebuilt SSO, we've rebuilt the email sending feature, we've rebuilt core feature X, but we've not built another feature. how are we going to release a user experience that's usable by our customers if we're missing one of the features the product already had? Now, if it's a low priority feature, like some legacy feature that's used by some early customers, but not by many anymore, or maybe isn't used by anyone, but we don't have the analytics to know it, it's a lot easier to handle these situations. We can run an opt-in beta program where customers can choose to move to the new application, knowing they're losing that particular feature. We can maybe remove that feature entirely. If it's not worth the return on investment to rebuild it, we could actually drop it from the product. And finally, we could actually target user segments to move automatically when we know they're not using that legacy feature. It becomes a lot more difficult when it's a core feature to the product that we've not necessarily rebuilt in the new domain, in that new migrated version. For a user experience to still be holistic and have all the features and functionalities we need for our application, we're very much going to have two systems and a user experience that spans those two systems. We then need to make sure the design of the old system isn't impacting the design of the new system in whatever interface we have going between them. We need to manage the communication between those systems, and we need to plan the stages of that migration. And this is what leads us to minimum viable migrations. Now, an MVM for me is a usable migrated version of an application from one domain or paradigm to another with a subset of the features to be used by some or all customers. It might be that we don't have all the features, but some customers can already use it, and it might be that for some parts of the features or functionality, it goes on the new technology, but for other parts, we're still using the old system. Now, for those of you familiar with the strangler pattern, of course, this is very familiar. MVM is really a framework that's a step-by-step guide for taking a strangler fig approach to migrating from legacy and modernizing an application. And each MVM in this process is a stepping stone in a strangler-style migration from legacy. So why do we want to use an MVM approach? Well, it's very similar to the reasons of using MVPs. We can learn faster, we can test assumptions much earlier, we can deliver value to customers faster, and we can focus a team on a culture of delivery. When we're talking about migration to something like serverless or something more cloud native, it's often part of a larger digital transformation where we're trying to change a team to have high deployment frequency or higher experimentation. Now, with the migration project itself to move to the technology that's rumored to let us do this faster release cycle or this greater experimentation, if that migration project is itself a big bang release that takes 2 years, have we really moved the culture of the organization to focus on delivery? Probably not. So by actually taking an MVM, more iterative and more progressive migration strategy, we can actually bring the team along to start to move towards that cycle of release, which we're looking for, so it can actually help the digital transformation the migration might be a part of. Now, going back to our two domains, our as-is and our to-be. As-is what we have already, to-be what we want to get to. And if we think of two systems running in parallel with bidirectional communication, and maybe 3 different features, feature A, feature B, feature C. Gradually, we're going to rebuild features in the to-be system, and we're not necessarily going to delete them from the old system, but they're not going to be running in the old system anymore. So we get sort of a progression until the as-is system no longer exists. And gradually, we build up a to-be system that has those different core features and functionalities. And those systems between, from the as-is to the to-be, are the progressively evolving systems between. And that's quite an unbounded set. And actually, a spoiler for the conclusion of the talk, there is no final to-be states. We need to move to architectures that are a lot more evolutionary, that can gradually change as technology changes. But to have this approach of 2 systems in parallel for the progressive migration, the communication channel is probably the most important aspect. If we do it in the wrong way, we're going to couple the design of the new system to the constraints of the domain model of the old system. And also, if we do it in the wrong way, it's going to be a very heavy engineering effort to make the whole thing work. So it looks easy, right? Well, the requirements for an MVM are actually quite familiar to people at this conference because we're really building an event-driven architecture. If we build our list of events from the domain model that's independent of the underlying implementation using domain-driven design techniques, we can actually have a common protocol of events between the 2 systems, the legacy system and the new system, that is common because it's based on the business domain, not on the underlying implementation. If the new system happens to be event-driven, which most new systems are starting to move towards, we'll have an event bus in the new system, and we can actually have those events from the business domain coming from the legacy system into the new system. And I'm going to talk about that ability to emit events in a minute. Finally, we need the ability to react to events, and I'm also going to talk about that a little bit later. But really core to this is an event-driven communication channel between, yes, the two systems, the as-is and the to-be, but also an event-driven communication channel as the core mechanism of the new architecture, meaning that, yes, we get the benefits of an EDA, but also as technology changes and we maybe migrate again in the future, we're already based off events, which makes that evolution a lot easier. Now, a quick sidebar on event storming, because we obviously need that list of events from the business domain rather than from the technical aspect. Now, domain-driven design, I'm sure a lot of you are familiar with, and event storming is an extension of domain-driven design that helps us discover many things, like our aggregates, our entities, our bounded context, and all of this is super useful in designing the systems and the architecture. But one core thing that comes from event storming, as the name implies, is a set of events, and they are business events rather than technical events. They're typically worded in the past tense, order placed, item dispatched, payment succeeded. And for those of you who've done event storming, this will look very familiar. It's a collaborative workshop where you get different people from across the organization, technical, business, different business silos, all into the same room. You find consensus on some things, and you also find areas where there's a difference in understanding of domain or difference in terminology, and that's where bounded contexts help us to plan our microservices more effectively. But today, we're just thinking about the events, getting that list of events from the business domain, things like order placed, item dispatched, which are going to be the communication protocol for our new architecture, which is going to be event-driven, but also for that communication protocol with the existing system. And at Alios, actually, we've been working with a lot of clients doing event storming and building in serverless. So event bridge storming is a slight expansion on top of event storming, where we take that set of events we talked about a moment ago, we build that into an event schema that's very detailed on the entities and the attributes of the events, and we tie that into event bridge to create quite a holistic event-driven architecture. And that schema is going to be super useful when it comes to figuring out how we're going to tie that legacy system to the new system. So at the output of an event bridge storming session, typically we have something like this. A number of different services. Maybe we have, this was actually a video conferencing application, things like polling, things like Q&A, all communicating asynchronously via events over something like Amazon Event Bridge, and then having the actual event schema, the breakdown of which events, their names, the types of the attributes, potentially stored in something like Event Bridge Schema Registry, but as a common protocol agreed between teams. Jumping back to minimum viable migrations, we've talked about the need for a more progressive approach. We've talked about how MVMs can be those stepping stones. And we've talked about how events are the key protocol to making not only our new architecture work, but also the communication between systems. But how do we get those events from the existing system to match the list of events we've just come up with in domain-driven design, when probably our existing system was not event-driven and almost certainly wasn't based off the same business domain events, because probably we didn't do something like event storming in DDD, and probably the business domain and the world has changed a bit since that existing system was built. And this is where we combine two things, eventification and ACLs, anti-corruption layers. So if we want to get a stream of events from a legacy application, and let's imagine we have a big legacy monolith that's talking to a legacy database. One thing we can do is change data capture at the database layer. So we can get different database triggers or different database logs to actually stream events over to our event bus. We can also have application code triggers. Maybe we don't have access to the database. Maybe the database is a bit too messy. We can actually drop application code triggers that will dispatch events to something like Amazon Event Bridge. One of our projects that I'm working on at the minute is for an airline migrating to fully serverless on AWS from an on-premise legacy application. And we've actually made changes in the .NET legacy code to directly use the AWS SDK to push events into Amazon Event Bridge. So that's the on-premise pushing events directly into EventBridge of the new architecture that enables us to react to things happening in the legacy system. Finally, if you don't have access to the application code or the database, logs can be another change data capture technique. Maybe it's application logs, again, maybe it's database logs, but you can automate some eventification if the logs are of a high quality. Regardless of the eventification strategy you take, and if you look at event-driven architectures and eventification, there's way more on that topic than I've just gone through. But regardless of the technique that you use, an anti-corruption layer is key. We're going to have different domain models in our existing system and our new system because of the reasons we spoke about earlier. The existing system is a lot older, the existing system maybe didn't do so much thorough domain-driven design, and the business has probably changed. So an anti-corruption layer enables us to translate between domains and make sure the domain integrity of the new system is not impacted by the domain model of the existing system. And here, the ACL has a very clear job. It's converting events from the legacy structure, which might be a collection of different database events, into those domain-driven design events that we've come up with for the new system. So that ACL is communicating the protocol of the existing system's eventification into the event-driven events that we're using in the new system. And making sure that this is the responsibility of only one team is key. We don't want every team keeping both models of the domains in their heads. If we have a dedicated ACL team, they take the cognitive load of that translation, of understanding both models and also understanding the technical implications of how they need to do the translation. But every other team working on those 4 independent microservices or services, they can work completely independently of understanding the complexity of that translation and understanding the complexity of the legacy application domain model. So we've talked about the need for MVMs, we've talked about how domain-driven design can help us build a list of events, and we've talked about eventification and ACLs to get that stream of events in the correct protocol. The next part is how do we start to put stuff live? And this is where we come to injection strategies. So back-end only systems are much easier because basically it's just routing. Either we add routing into the legacy application to go to a different back-end or to forward onto a different service if that feature has been rebuilt in the new application. Maybe we intercept between, and we can also use edge routing to jump in between and switch between routing to 2 different back-end systems. But when it's a full stack application that we're migrating, it's a lot more complicated. The user's loaded the application in their browser, and now it's jumping between 2 different sites. So micro frontends, and if Luca's in the room, I don't know if he is, but if you see Luca around, he's the expert on micro frontends, he's here today. Micro frontends are a really great technique in having multiple teams building an application that can deploy independently. So it's very similar, as you can think of microservices, but doing it on the front end. So maybe you've got a web page that has a basket for an e-commerce. A basket team can be independently deploying that basket while the rest of the page is built by a different team or multiple different teams. And there are 2 different types of micro front ends that are very useful when it comes to injection. And coupled with that, edge routing at the CDN layer, so actually not redirecting requests, but actually moving requests onto a different system, maybe using something like CloudFront Functions or Lambda Edge on AWS, is a really powerful technique to enable these different injection strategies. If we look at an example of having a client, so a client's loaded its browser, and we're looking at let's say an e-commerce application with 3 pages. The first page, it's going to go through the edge router, and the edge router knows which pages have been migrated, either via static application code or by using edge-level databases. So it goes to page 1, it knows that's the old system. The request comes through for page 2, or the request comes through for page 2, it knows to send that to the new system. Not a redirect, but actually sending the request onto a different destination. And finally, page 3, it knows it's the existing system that it needs to default back to. Very easy for templated websites. When it comes to single-page applications, you have to do a little bit more complexity because you've got that front-end level routing. There's a couple of ways of doing that. If you're interested, feel free to grab me after the talk and we can talk about that. The other strategy is horizontal. So vertical, taking those vertical sections, those whole pages. Horizontal refers to the fact that this micro front end could appear on multiple pages. If we take the example of another website, let's say a cinema booking website, where you can see a summary bar of your booking, you can search for different shows, and you can also see featured products. In the legacy application, maybe that featured product section was actually hard-coded by the application developers. So when the marketing team wanted to have new featured products, they actually had to go and raise a support ticket and get application code changed. In the new application, we're going to have a shiny new CMS, something like Contentful, where the marketing team can actually change the products themselves. How can we put that live before we've migrated the search system and before we migrated the booking summary? This is where horizontal micro front-end techniques can be really useful. In the most sort of naive approach, we can just drop an iframe in, and that can load our different parts of the application, but that's not a great user experience, and it can get quite clunky when we need to start to share state between the different micro front ends. We can potentially build an orchestrator, which is basically a shell application that's going to bring in the different components, but that creates some complexity as we sort of have to micro-frontify some of the existing aspects to be able to be dropped in that way. One of the easiest ways is to get a small amount of JavaScript added in by the existing team into the page, and dynamically at runtime, that JavaScript can create the DOM elements that's then going to have the micro front-end injected into it. And server-side rendering techniques with Next.js, which is a front-end React framework, can do things like Webpack federated modules, which makes it easy to bring these in with a much better experience for the customer. But in the most naive sense, an iframe can work. And in some applications, especially not customer-facing, that can be the quick and dirty way, but a very fast way to start to get the migration in place. So we've talked about how to inject, we've talked about the need for MVMs, but how long is an MVM and how do we plan the roadmap of the MVMs? So the typical rule of thumb I've been using with teams and what we've seen work well is an MVM typically being less than 8 weeks. So the migration project for the airline, which I talked about earlier, initially they were planning to spend 2 years building it, releasing it, it was going to work, and then they were going to turn off the old system. I imagine that would not have happened. We instead took a lot more progressive approach and split it into MVMs, each lasting 8 weeks. So every 8 weeks, new parts of the system are being migrated, and after those parts of the system are migrated, they then have a much higher deployment frequency. Each MVM should be linked to one and only one bounded context from domain-driven design. Bounded context, let's just view it as an area of a system for the purpose of this talk. It should really be only one team working on that particular MVM so that their cognitive load is not across multiple things all going live in parallel, and they can have a lot of focus on that individual delivery to production. We should know the dependencies. Potentially, you're going to have MVMs dependent on other MVMs going live, so you need to think about that. Potentially going to be dependent on state transfer from other MVMs. That needs to be considered. And potentially, you're going to have third parties that need to whitelist new IPs or add new sort of endpoints. We also need to know the ROI for a particular MVM. So obviously, we're doing a big migration. Everything's going to be a lot better, faster, stronger. But each individual MVM can also add value. Maybe we're going to migrate the payments section of an e-commerce page. If that's also going to enable the company to add Apple Pay to increase conversion, that's a massive return on investment. And tying the development team to the ROI, not only of the overall program of migration, but to that individual MVM, creates a lot of focus and a lot of motivation inside of that team. And knowing the ROIs also helps the business to prioritize which MVMs should go live first. And finally, of course, it needs to be injectable. We need to know the injection strategy for every MVM to know that it's viable to put live in this way. Putting that together, I've typically built what I call an MVM priority matrix. So we break down all the different MVMs that form an aggregate application. We know the domain that each MVM relates to. We know the scope limitations, and limiting scope is really important. Let's say we're migrating the payment page of that e-commerce. Doing that globally is quite a big job. 8 weeks seems a bit punchy, but maybe we're going to do it for UK-only card payments. We can start to really limit the scope of MVMs, and our edge routing can use things like geolocation or can use context of requests to know which of the payment systems it's going to use. And finally, the injection strategy, as I mentioned, and any other dependencies. So looking at an example of one of our e-commerce projects at the minute with a few things sort of removed, we can see 3 MVMs. And we can see the domains they relate to, the injection strategy, vertical or horizontal micro front ends, the feature we're building, card, filtering on search, or subscriptions on payments, the scope limitation. We've got 2 examples of geographic scope limitation, and dependencies. Here, there's a dependency on Stripe. It's not a full example. It's a much longer list of about 92 MVMs, and that team is putting an MVM live every 8 weeks with 6 teams in parallel. So there's quite a high frequency of these MVMs going live. So we've gone over quite a lot. We've gone over why do we need MVMs? We've gone over how event-driven architectures are fundamental to the actual migration and also the application being able to evolve afterwards. We've seen the importance of those events coming from the domain model and how that enables us to be above the implementation when it comes to that communication channel. We've seen different injection strategies. We've also seen how do we prioritize and how do we scope limit our MVMs. So concluding on that, and going way back to the start, feature paralysis is the big issue. That's what's stopping us from being more agile in our migration projects to cloud and leading to those big bang releases, which are not particularly fun to be on call during. MVMs also allow us to learn faster, test assumptions faster, and most importantly, deliver value to our customers more quickly. They also focus the team, and when this is part of a large digital transformation where the new technology is supposed to enable this faster delivery or this increased experimentation, well, actually, the migration project itself should embody that faster delivery and that more agile approach. Each MVM is a stepping stone on the journey, and you can have as many or as few as you want, but the more you have, typically, the more assumptions you test earlier and the more success you start to have with each subsequent MVM. And there is no final system. This is something that continues even after the migration as technology continues to evolve. Change data capture and an ACL can provide us with that stream of events that enables this whole system to work, and micro front ends and edge routing in combination are really useful injection strategies for full stack application migration. The event-driven architecture is key to this. This is what provides that clean interface. And event-storming, which is a domain-driven design technique, is really useful in actually bringing that list of implementation-independent domain events. And we can divide into as tiny a granularity as possible on our MVMs, and this all impacts cycle time and management overhead. Yes, there is an overhead for taking the MVM approach, but I've typically found the projects that have taken the MVM approach go faster than the projects that try to do the big bang because we learn so much faster and the team is so much more focused. But you don't want to go as small as an MVM every day because that injection strategy and the planning is an overhead and there is a management cost to that. If you're interested in the MVM stuff I talked through today, we're publishing this in the next couple of weeks, which goes into way more depth on every step of how we've done MVMs, and that's open and public, so feel free to have a look through. If you have any feedback on it, I'm always happy to hear it. But really, that's been my summary of how we've used MVMs. We've used them for mid-sized scale-ups through to some of the world's largest companies, airlines, and financial institutions. So if you have any questions on sort of different levels of taking an MVM approach, feel free to ask any questions now, I think through the app. And my team are also around today, so you can feel free to grab any of us for any questions. Thank you.